Hello and welcome to a second installment of Mr. Viola's Physics Classroom, Dimensional Analysis Review. So freshmen, we have a quiz this week. This video will just be going over some basic review of dimensional analysis and unit conversions to make sure you're all prepared. So the first question we had to do with what to do if I have to convert something, for instance, 65 miles per hour. The first thing you want to take note of is that it's not written mph, but that I write miles over hours to keep myself straight on my dimensional analysis. So if I want to go 65 miles per hour and I wanted to convert to something like kilometers per day, I would start as I always start, fraction bar, multiplication sign. If I have a choice at this point. If I want to go from miles to kilometers first, I can do that. If I want to go from hours to days first, I could do that as well. So I usually like to start with what's on top because it's most familiar. So we'll put miles on the bottom. And I want to go to kilometers. So there's several ways you can do this. Like I said, there's 1,000 ways this can be done. If you know how many kilometers are in a mile, that would be the easiest and quickest way to get there. If not, you can go miles to feet, feet to inches, inches to centimeters, and then work your way back up to kilometers. But this is the quickest and easiest way. So now miles is canceled out. I'm left with an answer in kilometers per hour. My goal was kilometers per day. So now I take hours and I put it on the top of my fraction. So it's important to remember that if I'm canceling something out, it's going to be the opposite side of where I started. So I'm going to days, and I know there's 24 hours in one day, so my hours has now canceled out, and I'm left with units of kilometers per day. Now my last step to this problem is simply to take 65, multiply by 1.6 and 24, and then divide by the bottoms, which in the case of this problem are all ones. So if I grab a calculator, 65 times 1.6 times 24 gives me 2,496. So 2,496 kilometers per day is how far I would travel. There are other problems where I could use something like this as well. We've done a lot of miles per hour. If I had something different, so if you go on the practice exam for the honors level, and you look at one of them, number 3 wants to know pounds per inch in grams per centimeter. So we have 7.44 grams per centimeter, and they want us to go to the pound per inch. So again, I have two units that are going to both be changing, so I can choose which one I want to start with. Grams is going to go to pounds, so perhaps I start there. Because grams is on the top, it's going to go to the bottom. I don't know the conversion from grams to pounds, so we'll go to kilograms first. In 1 kilogram, there are 1,000 grams. So I've gotten rid of gram. And then from kilograms, I remember that there are 2.2 pounds in every kilogram. So I've canceled out my kilograms. I've got my pounds on top, that's what I wanted. And then from centimeter to inches, it's a one-step conversion. Keep in mind again, centimeters is on the bottom, so to cancel out it needs to go on the top. In 1 inch, there are 2.54 centimeters. And before I even do any math, I know that my units are correct because I'm in pounds per inch at the end. So that's one of the ways to check yourself, is make sure that when you cancel out your units, the only things you haven't canceled should be the units you're going to. In this case, pounds per inch, and we're in good shape. So if I put this in my calculator, 7.44 divided by 1,000 times 2.2 times 2.54 gives me 0.041 or 0.042 pounds per inch. So in these two examples, you can clearly see how to convert when I have 2 units instead of just 1. Some of the other things that you might see in your exam would be some word problems. So one of the more difficult ones would be again on the honors review packet. Number 6, when you're throwing a pizza party for your 20 closest friends. It says you figure each person will eat 3 pieces, and you learn that each pizza will cost you $17 and you'll be cut into 10 slices. So how much is the pizza going to cost you? And if you have $128, will you have enough money? So let's figure out what our important information is. We know that 1 pizza is going to give me 10 slices. I know that each person is going to eat 3 slices on average. And I know that I have $128 and each pizza costs 17. So 1 pizza is $17 and I have total $128 to spend. So the first thing I need to figure out is how many slices am I going to need? And in this case, we've invited 20 of my closest friends. Presumably you would like to eat as well. So there are 21 people at this party. Those 21 people are each going to eat 3 slices. So 21 people. And we can convert each person as 3 slices. So 1 person, 3 slices. So people or person cancels out. 21 times 3 is 63 slices. So I'm going to need 63 slices of pizza. Which means when I look at this, I know that each pizza is 10 slices. So 63 slices. And again we multiply. 1 pizza over 10 slices. So I'm going to need 6.3 pizzas. This is a real world problem. I can't order 6.3 pizzas. Logically, I would need to order 7 pizzas. So I need 7 pizzas to feed everybody, including myself, for this party. Each pizza is $17. So 7 pizzas times $17 for 1 pizza tells me that I'm going to need $119 to order 7 pizzas. I have $128, so the answer to this problem would be that yes, I do have enough money to order enough pizza for all of my friends to eat at my party. This is one of the problems where perhaps using 6.3, you still would have gotten the correct answer, but you would have had some of the wrong numbers, and it got pretty close. So you want to really make sure that you're using some common sense when you answer these. So 4-dimensional analysis, we can use it in many different ways. And some of them will be fairly simple. So some of the one-step dimensional analysis problems that we've done include if I take my weight and I want to convert that into kilograms, it's just a one-step problem where I can pretty easily go with 190 pounds and I divide by 2.2 because it's on the bottom of the fraction. And I get about 86.4 kilograms. If you're looking for some conversion factors to memorize or in the CP courses to put on your note card, I would suggest the following in addition to what I've already given you. So 1 kilogram is 2.2 pounds. 1 gallon is 3.78 liters. 1 meter is 3.28 feet. 1 inch is 2.54 centimeters. And 1 kilometer is 0.6 miles. You could also use this the other way and say that 1.6 kilometers is 1 mile. Those are interchangeable, they can go both ways. Other than this, if there's anything that you really feel like you need, and you really want to make everything one step, you can put anything you want on that note card, or you can, for the honors class, memorize anything you want for a conversion. The last part of the quiz is simply our unit conversions, which, as a quick reminder, we have our base unit, which is the meter, the liter, and the gram. And then going up, we go deca, hecta, kilo, and going down goes deci, centi, and milli. Remember, as we move to the right along the continuum, our decimal point is going to move to the left. So you want to keep in mind that whichever way you move, the decimal is going to move in the opposite direction. If you have any further questions, please come in and get some extra help before your test day.